Today we'll be creating a trapezoidal load on the face of a beam meshed with solid elements. The trapezoidal load will vary between 10 and 20 pounds across the span of a 24-inch long beam. We'll begin by opening the CAD geometry and creating our simulation files. We'll also create a linear static solution to test our model. Alright, so first we'll create a fixed translation constraint. Here I have a couple of edges that we'll apply that to. And then we'll create our trapezoidal load. So here we'll create a force, magnitude, and direction. We'll specify the face that we want to apply the load to, and then we'll take the mean of the ends of the trapezoid. So here we had 10 on one end, 20 on the other, so the mean will be 15. We'll specify the direction being normal to the face or in the negative YC direction, and then a spatial distribution. And here we'll create a table field with a Cartesian independent domain. And we'll use the Delaunay accurate interpolator. And then we'll create our table field. We'll use the spreadsheet to create our table field where we'll specify 8 points that define a hexagonal volume that will encapsulate our beam. We could use the exact 8 points of our beam, but here I'm only ensuring that I'm selecting endpoints that define a plane on the ends of the beam. For the dimensionless value, we'll divide the load at the end of the beam by the average load. So here we'll do that for the 4 points on one end of the beam. And then we'll complete the other 4 points. And that specifies one end of our table field. Now for the other end of the beam, which is 24 inches in the X direction, we'll use the same Y and Z dimensions for creating our hexagonal volume. And then the load on the other end will be also divided by the mean load to get our dimensionless value. Once we've completed the specification of our table field, we could go to Add-ins Update Table, or just simply X out of the spreadsheet, and then say OK to the question, do we want to update the table field? Alright, now that we've created our load, we can see a representation of that trapezoidal load. If we want to see how it maps onto a mesh, let's go ahead and put a mesh on our beam. Here I've created a brick mesh. And now we can plot the contours for our trapezoidal load. To see this a little bit better, let's go to the results ribbon and change the view to a contour view. And here you can see how the load varies across the span of the beam. To ensure that we've got the correct total load, we can sum the load on the face to see that we've got our average load there of 15 pounds. And we can also create a graph of the applied load across a query curve that spans the length of the beam. So here I'll specify 2 nodes that will define the endpoints of a query curve. And if you don't see it selecting the nodes, you'll need to adjust the distance to mesh tolerance and duplicate location tolerance. And here we can get a plot and see how that load varies linearly across the length of the beam. Here we'll probe some of the locations and set some markers so that we can see the values at the very end of the beam, which should be half of what it is the next node in, or roughly there so. And also at the other end, we can set markers to see what those values are. So here we can see that the load varies by a factor of 2 across the length of the beam. Next we'll do a test solve. And here I'll pause the video while it's solving, but it only takes a few seconds. And then we can view our results. We can also create this load with a more elegant solution using formula fields. So here we'll create a new formula field, and we'll use Cartesian. And our beam is going off in the x direction from x equals 0 to x equals 24. So we can create a formula that would come up with a value of 0.66 when x equals 0 and 1.33 when x equals 24 to give us the exact same result as what we created earlier with the table-based field. So here if we interrogate the contour of the applied load, we can see the total average is 15, and we can also create the query curve that we created earlier to see how the load varies across the span. And here we'll probe the curve for its endpoints. One node in from the end of the beam, we'll set a marker. And one node in from the other end as well. And here you can see that that varies by a factor of 2. And that concludes the demonstration.